Welcome to part 2 on this lesson on integration by partial fractions. In the previous part, we practiced on the concept of expanding fractions into smaller ones. And in the second part, we're going to apply just that to some integrals. So we're going to do 3 examples in 3 different videos. So stay tuned. Before we move on, there's something I want to show you. So I wanted to show you this summary that I have. If there's just one thing you can get out from this lesson, for me would be this. It's important for you to remember that when it comes to solving integrals by partial fractions, the first step to expanding fractions is to verify if your integrand is a proper or improper rational function, because if it's proper, you're good to go, but if it's improper, you either have to use long division or synthetic division. So always remember that. And then the second step after that would be to factor that denominator and do the partial fraction expansion accordingly. So if it's linear, you expand that n times, you put constants on the top. But if it's irreducible quadratic, which you already know what that is, we expand into n new fractions with linear terms in the top instead of just constants. And then finally, you just integrate. Most of the time, like 99% of the time, you can integrate it using u sub, and sometimes you can integrate directly. Now, let's try a first example. Alright, so for our first example, we have the integral of 3x plus 11 over x squared minus x minus 6 dx. And the first thing you should do whenever you see an integral, especially if it looks like this, is you ask yourself, can I solve this using u substitution? Because this is the most basic technique for integrals. Now, if I say u equals 3x plus 11, then du is going to be 3 dx, which is not going to help me, especially for the denominator. And if I pick the denominator, u equals x squared minus x minus 6, then du is going to be 2x minus 1, which is, it doesn't really fit what we have in the numerator, right? So I have problems. Now, since I know it's obviously a rational function, the next logical thing to think is, can I use partial fractions to simplify this process of integration? So let's try that. Let's see what happens. So for this process, we know from the previous videos that there's 3 main steps you need to consider. Step 1 is to ask yourself, is the rational function, the integrand in this case, is it proper or improper? Well, it's proper because 2 is higher than 1, so we can move on to our second step, which is to verify if the denominator can be factored or if it's in its simplest form. In this case, let me write down the integrand, x squared minus x minus 6. In this case, it can actually be factored, because if I set 2 parentheses and x on each side, because we have an x squared, I know that minus minus is plus minus. In this case, 2 minus 3 is going to give me minus 1. 3 times 2 is 6. So the 3 goes into minus and the 2 goes into plus. And this works and it gives out this. So we're good to go. It does factor. And now these 2 terms are simple linear terms. They obviously cannot be factored any further. So in conclusion, what we have is 2 linear terms. Technically, there's an n equal 2 in terms of we need to create 2 fractions over here. So therefore, we need 2 variables or 2 constants on the top, on the numerator. So I'm going to say a and b, and one of them is going to be for x plus 2, the other one is going to be for x minus 3. Next step is to perform the smiley face to get our third expression, which is going to be useful to find what a and b are. So I'll get a times x minus 3 plus b times x plus 2 over, we don't really need to write the denominator, as we know from the previous videos, it's always going to cancel. Remember also that I call these expressions 1, 2, and 3 because I always compare 1 and 3 first, and then I use expression 2 for my final result as a reference. So comparing 1 and 3, I can get rid of the denominators, and I have 3x plus 11 equals a times x minus 3 plus b times x plus 2. I can solve this very easily by setting 2 specific values for x. If I say first that x equals to 3, I can get rid of the a term, the a variable, and solve for b value, which is going to give me 4. And if I say let x be equal to minus 2, the opposite is going to happen. I'm going to find out that a is equal to -1. So verify these two results if they're good. And then we can move on to say that the integral of 3x plus 11 over x squared minus s minus 6 dx can be expanded into the integral, or rewritten as the integral of a, which is -1, over x plus 2 plus b, 4, over x minus 3 dx. Now we're just halfway done because we've only dealt with the integrand. We haven't solved the integral per se. And now we ask ourselves the same thing again. Can we solve this new integral, this new re-expressed or rearranged integral using the basic techniques, u sub or direct integration? Well, yes, we can use u substitution here to solve this. Now, if you already have a little bit of experience with u sub, you know that this is going to give me 2 natural logs. So if you have some experience with this, you can just integrate directly because you know that the denominator is raised to the first power. There's an x to the first power. If you don't have experience, then consider u equals x plus 2 for the first one, and u equals x minus 3 for the second one. You have to split it into 2 integrals. You get the same result. Anyway, I'll get the negative natural log absolute value x plus 2 for the first term, and for the second one, I'm going to have a plus 4 times natural log of x minus 3 plus c. Don't forget the c. And we're done. So let's take a look at a second example.